Okay, we're going to go on to lesson 24. This is section 5.2, Trigonometric Functions, part 1. And so this lesson, this section 5.2, I broke it up into 2 parts. So that will be both lessons 24 and 25. So when you see on the homework that 5.2 is in both, you'll see that I split the homework up into 2 parts. Okay, and so last lesson we talked about just angles. Well, now we're looking at a complete triangle, and of course with a triangle it has 3 internal angles in it. But here we're referencing to theta. Back up. We're referencing to angle theta here. So when we say the opposite side, we're talking about the side opposite of angle theta. And the adjacent angle, that's the angle that's adjacent to angle theta. So we're always talking in terms of the internal angle that we're trying to get the values from. And then the hypotenuse, that hypotenuse is always what in reference to a right triangle? It's the side that's always what? Opposite the right angle, that's right. So you can use this. I like to use the mnemonic phrase SOHCAHTOA, where S for sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So here's sine, opposite over adjacent, opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Okay. There are other angles which we call the reciprocal angles, which we'll get into a little bit later on. But once you know these, the reciprocal angles are a little bit easier to identify with. And so here we go. We have sine. This time we're using t instead of theta. You can look at theta as a variable. Well, t, you can also use t or angle alpha, or different variables can be used instead of just theta. So sine, again, is opposite over hypotenuse. Cosecant is the reciprocal of sine. So if sine is opposite over hypotenuse, cosecant, all you're doing here is you're just flipping the 2 sides. So cosecant is hypotenuse over opposite. Cosine is adjacent over hypotenuse. So its reciprocal secant is you just flip it. Hypotenuse over adjacent. Tangent is opposite over adjacent. So cotangent is this reciprocal identity, and that's adjacent over opposite. So it helps to write down sine, cosine, and tangent values, and then just for the reciprocals, all you do is just flip the sides. Okay? So those are the 6 basic trigonometric identities that we're going to be working with. All right, so when a question is asking you, gives you an angle, and it says find the 6 trigonometric identities, this is what they're talking about right here. Find those. Okay? Questions with that so far? So some confusion that people make is they see sine and they want to connect secant with sine. But think of it in terms of, the C and the S's are switched for the reciprocals. So sine is reciprocal is cosecant. Cosine's reciprocal is secant. Sine is cosecant. Cosine is secant. Okay? Tangent's easy. That's just cotangent. Okay, here we have a terminal point on the coordinate plane, 8, 15. We want to find the values of the 6 trigonometric functions. Well, it helps to draw it out. So we always start from the origin, 0, 0. And the vertex always goes out from the origin. And so x coordinate, x is 8. The y coordinate is 15. Well, we need to find the hypotenuse, or also known as the radius. Well, we talk about radius when we're talking about unit circle. We talk about hypotenuse when we're talking about triangles. So in this case, radius and hypotenuse are synonymous with each other. So we have to use the Pythagorean theorem to get the third side. And so that would be 8 squared plus 15 squared, and we get 17. Now the hypotenuse is always, always, always positive. The hypotenuse is always positive. Now x and y, those can be positive or negative depending on which quadrant you're in, but the hypotenuse is always positive. Okay? All right, questions with that? So we have our 3 sides. So from here we can come up with our 6 trigonometric functions. So in this case, sine theta would be opposite over hypotenuse. So we could say sine theta is 15 over 17. And so therefore its reciprocal cosecant would be what? If sine is 15 over 17, then cosecant would be what? Travis? 17 over 15. That's right. You just flip it, or apply the reciprocal. Cosine is adjacent over hypotenuse. So that would be 8 over 17. So secant, Harley, would be what? If cosine is 8 over 17, then secant would be 17 over 8. That's right. And so from here we can find our 6 trigonometric values. So we said sine was 15 over 17. Cosecant is 17 over 15. Cosine we said was 8 over 17. Secant 17 over 8. Tangent is opposite over adjacent. So that's 15 over 8. Cotangent is 8 over, you just apply the reciprocal, 8 over 15. All right, and so that's pretty straightforward there. All right, questions with that? Now the only problem, the biggest problem that students have are the signs. Now notice this is in the first quadrant, but if we were in the second quadrant or third or fourth, the x value is negative. In the second quadrant, y value is positive. So you have to watch what quadrant you're in when you do these. Okay, because if you just ignore the signs, then they're wrong. They're not going to be their correct values. Okay, so here we have the hypotenuse is synonymous with the radius. In our unit circle, here's our x values, here are our y values. So when we're looking at x and y, you just look at your x coordinate, that's your x value, your y coordinate, that's your y value. All right, so let's try another problem. All right, so let's try this. We want to find the 6 trigonometric values. We're going to find the 6, and I'm just going to abbreviate it, trig values for 8, negative 15. So basically, here, you want to draw your coordinate plane. Okay? Here's your x, here's your y. X is positive in the first quadrant, but also x is also positive. If this is quadrant 1, 2, 3, 4, what quadrant are we in? With a positive x value and a negative y value. Sydney? Fourth quadrant, right. Okay, so here we have our x value is 8, our y value is negative 15, and this is similar to the last problem, right? We already know that the hypotenuse is 17. Now keep in mind, you always start from the origin and work the terminal side out. Okay? So here's angle theta. All right, so your angle theta is always from that angle that's at the origin, okay, where the vertex is at the origin. Okay? So now we're going to do sine, cosine, tangent, and then do the reciprocals. All right, I'm not going to write them down. Go ahead and do those. Go ahead and try that. And remember this, so, ka, toa. Okay, so sine, that's opposite over hypotenuse, right? Cosine, adjacent over hypotenuse. Tangent, opposite over adjacent. Okay, what's sine? Remember now, it's opposite, the side opposite angle theta. So even though this triangle is upside down, right, you're always going to have an adjacent side and an opposite side. So the opposite side would be what? Dylan? Negative 15 over the hypotenuse? 17, right. Because here's your perpendicular symbol, right? It's always going to be in reference to the x-axis. Okay, so therefore, I gave it away, didn't I? Cosecant is going to be the reciprocal. And so what would that be, Harley? 17 like that? Or over negative 50? Yeah, but you can put the negative out to the side like that. Okay? Because the negative in the denominator is not considered in its most simplified form. Okay? Okay, Harley, how about the next one? Cosine. What's that going to be?
17 over 8.
Remember now, it's going to be adjacent over hypotenuse.
Oh, no. 8 over 17.
Right. It's going to be 8 over 17. And so what's the reciprocal identity for cosine?
17 over 8.
Yeah, well, I mean the name, you know, is it cosecant? It's not cosecant because we already used that. So what would be the next one? Secant, good. Secant theta, and you already said it, that's 17 over 8. What we're doing is we're just taking the 8 over 17, you're flipping it. Okay, how about tangent? Travis? Negative 15 over 8. Good. Opposite over adjacent. And what's the reciprocal identity for tangent?
Negative 8 over 15.
Okay, and what do you call that? It's, just think of tangent with a C and cotangent. Okay? All right, and that's your 6 trigonometric identities right there. All right, questions with that? Okay, so moving on, we have our point xy. We have our x value and our y value. R is synonymous with our hypotenuse. And in the unit circle, R is always considered 1. Think of unit, 1 unit. R is usually considered 1. Okay, so here's our 6 trigonometric functions. Notice sine is, if we look back, sine is opposite over hypotenuse. Well, if our radius is 1, right, then sine is going to be y opposite over 1 for our radius. Well, y over 1 is just y. So sine is synonymous with the y value. Okay, sine, if you're talking about sine and cosine, sine is synonymous with y. Cosine is adjacent over hypotenuse. So if we're looking at this, oh, that's right, we can't do that. If we're looking at this in terms of, let's back up. Cosine is adjacent over hypotenuse. And if r is 1, this would be x over 1. So cosine would be x over 1. Well, x over 1 is just x. So cosine is synonymous with x. Sine is synonymous with y. Okay? Tangent is y over x. So we can say tangent. So since tangent is opposite over adjacent, then we can say that tangent is opposite is y, adjacent is x. So since sine is y and cosine is x, we can also say tangent is sine over cosine. So we also use the identity tangent theta is sine theta over cosine theta. So it's reciprocal. Cotangent would be what? Well, we just flip it, right? And so cotangent would be what, Harley? In terms of sine and cosine. If tangent is sine over cosine, right? Yeah, cotangent would be cosine over sine. That's right. Okay. So cosecant is r over y. Since sine is y over r, cosecant is r or 1 over y. Secant is reciprocal, 1 over x, and cotangent, x over y. Okay, so you could also say 1 over cosine, 1 over sine here, 1 over cosine here for secant, and then cosine over sine for x and y. Okay. So since cosine is synonymous with x, sine is synonymous with y, at 90 degrees here, if our radius is 1 unit, then this point would be x is 0, y is 1. But we could also say cosine is 0, sine is 1. And since tangent is sine over cosine, tangent would be 1 over 0 or undefined. Okay? So that's 90 degrees. 180, and whether 180 is positive 180 or negative 180, it's the same point. Okay? Here, x is negative 1, y is 0. So cosine is going to be negative 1, sine is going to be 0 at 180. And tangent is sine over cosine. So that would be 0 over negative 1, as tangent is going to be 0. All right, at 270, here again the radius is 1, so x is 0, y is negative 1 on our coordinate plane, and so cosine is 0. Since cosine is synonymous with x, cosine at 270 is 0, sine at 270 is negative 1. Tangent is sine over cosine, so that would be negative 1, and 0 is undefined. So tangent at 90 and 270, tangent is undefined at those two angles. Okay? Questions with that? And then here we go back around, whether we're at 360 or 0, the values, we call these values or functional values or terminal point, depending on what textbook you're looking at. Whether it's 0 or 360, the values are the same. So this would be, again, radius of 1, x is 1, y is 0. So that would be cosine is 1, cosine of 360 is 1, sine of 360 is 0, tangent, sine over cosine equal to 0. Okay, so tangent at 360 or 0 is going to be 0. All right, questions with those? Main thing to look at is cosine is always the x value, sine is always the y value. Okay, find the values of the 6 trigonometric functions for an angle. Okay, at 90 degrees. What is cosine? Dylan, at 90 degrees. If we're looking at our value here, what is cosine? 0, very good. Cosine is 0, and what is sine? 1, very good. And so tangent at 90 degrees, we said is, think of it in terms of sine over cosine. Sine over cosine. 1 over 0, right? Which would be undefined, right? Okay, so we have x is 0, y is 1, r, of course, is 1. Our radius is 1. So sine is 1. So it's reciprocal. Well, you flip 1, right? 1 over 1 is still 1. So cosecant at 90 degrees is 1. Cosine is 0, but what is secant going to be at 90 degrees? Well, if we take 0 over 1 and we apply the reciprocal, now what do we have? It's undefined, right. Secant is undefined. Good. How about, well, we already know tangent is undefined. We already said that. Well, what about its reciprocal, cotangent? 0, very good, because this would be the reciprocal of 1 over 0 is 0 over 1, and so cotangent 90 is 0. Okay? All right, questions with that? All right, find the values of the 6 trigonometric functions of an angle at a negative 450. All right, so it helps to draw it out. We want to find the 6 trig functions for a negative 450 degrees. Okay, first of all, negative is going which way? Clockwise, counterclockwise, or clockwise for a negative angle? Clockwise, that's right. Counterclockwise angle is always positive. Clockwise the angle is negative. So here's, this would be a negative 90, negative 180, negative 270, okay, negative 360. But we're going to keep going, right? Because negative 450 is more negative than 360, right? So if we took negative 450 minus 360, right, then that's going to be, we got to borrow, right? So that'd be 90. So we're going one more time around. So basically, negative 360 is a whole turnaround plus 90. Okay, but it's the same as, so what is our value here? If our radius is 1, right? What is our coordinate point right there for x and y? Sydney? Well, x is not right here at this point. X did not move right, x did not move left, so x must be what? 0. All right, good. And so it's y in the negative direction, so that has to be negative 1, right? Because all our values are this is considered in unit circle, so our radius here is 1. So here's our cosine and sine, right? So now come up with our 6 trigonometric values for sine, cosine, tangent, and then the reciprocals. I'm not going to write them down yet. Go ahead and do that. Okay, sine, you should have gotten negative 1. Cosine, you should have gotten what? 0. Tangent is the same as sine over cosine. So tangent is going to be what? Yeah, undefined. So we're just going to abbreviate undef for undefined. I'll write it down below here so that we have more room for cotangent. Okay. Dylan, what is the reciprocal of sine? What is it called? Secant, cosecant, or cotangent? Cosecant, good. Okay, so sine is negative 1, right? So think of it in terms of, now flip that. negative 1 over 1. Always put the denominator in the 1 in the denominator, and now you just flip it, right? Which would be, cosecant would be what? Negative 1. Same thing. Cosine, right? Just put a 0 over 1. So therefore, Sydney, what would the reciprocal identity be called for cosine? Secant, right. So that would be secant theta. And so we just put 0 over 1. So secant is going to be what? Well, careful now because we got to flip that, right?
1.
It's going to be 1 over 0, right? Because we're taking 0 over 1 and we're flipping it. So that's going to make it 1 over 0. So really, secant is going to be what? Undefined. Good. Okay, and then we have cotangent theta is going to be what, Harley? 0. Good, because this would be like saying 0 over negative 1, so that would be 0. All right, good. Questions with that? All right. Okay, I also wanted to do another problem. So let's try this. Here we have find the 6 trig functions for negative 5, comma 0. So basically, instead of in the previous problem, instead of 1 being the radius, now it's 5. All right, so let's draw this out. We got negative 5, comma 0. Okay, so in that case, now you're going to do this 6 trigonometric functions. So go ahead and do that for sine, cosine, tangent, and their reciprocals. It helps to label these in terms of sine and cosine, or cosine and sine. So it helps it's a good idea to draw this out on the coordinate plane, and then from there go ahead and get your values. Okay, Travis, let's look at this coordinate point right here, negative 5, 0. Where would you put cosine and sine? Cosine is negative 5. Cosine is always synonymous with x. Sine is always synonymous with y. Okay, good. Okay, so therefore sine right, would be what? 0, right. So if we put that 0 over 1, its reciprocal would be what? Cosecant. Undefined, very good. Because that would be 1 over 0. So that's undefined. Okay? Cosine, what would that be? Harley? Well, look over here. What did we identify cosine to be on our coordinate point? -5. So now we put that -5 over 1, and what's the reciprocal secant going to be? That's right, -1/5. Good. And Dylan, how about tangent? That's right, because it's going to be, so this is 0, right? So tangent is always sine over cosine, right? So that's going to be 0 over -5, or just 0. Well, what about cotangent? Undefined, right? Because if you took 0 and -5 and flipped it, you'd have -5 over 0. That's undefined. All right, good. Questions with that? That help clear things up a little bit more for you guys? All right, good. Okay, and that is lesson 24.